The industrial capacity of China is fearsome.
Being able to deploy highly autonomous AI-driven drones at scale is still a domain that we can win in.
I think the technologies that matter most to the future of war are right there in front of us.
I think a modern conflict becomes basically like a software writing fight.
It will be the pace of deployment that is the make or break for militaries around the world.
The game theory here is just as simple and obvious as it can be.
Unless we find a way for industry and government to work together, we will find ourselves in a very tough situation.
We're here to chat about drones, autonomy, and great power conflict. Now, both of you have started incredibly successful and innovative drone-focused companies. At the same time, both of you started when the industry was truly nascent. It was seen as a field for hobbyists rather than something that could actually shape the future of warfare. So what led you to be interested in this field and to spend so much of your time, blood, sweat, and tears on this now incredibly important industry?
I had started and sold a company to Qualcomm, and I've always been somebody that has had, an intense, passion to compete, fight, win at whatever I was doing. And in my last year at Qualcomm, I was there for about 4 years. I didn't have that fire in the belly that I had had throughout my life. And so I started thinking about what it was that would really motivate me, not for the next 5 years, but for the next 50. And I decided that if I could find the intersection of three things: a noble mission, the chance to work with extraordinary people, and a chance to define the possible, I'd have that fire in the belly. My brother went on to become a Navy SEAL, so totally different track in life. He was getting ready to go to business school. I encouraged him to think about what he wanted to do in life. And he came to me with the idea of bringing the best of what was going on in the autonomous driving sector to the mission of protecting service members and civilians. He felt like if somebody would do that, it would have brought home a lot of his friends safely to their families. And he felt like it would be a pillar for the future of American military dominance. I thought it was an extraordinary mission. I told you earlier, I thought it was a stupid business. And so I wished him luck and suggested that he come up with a better business to make mission impact. But SEALs are very persistent people. My brother is no exception. And sort of long story short, I started to spend more time with him learning about the challenges, and I was just shocked by the scope of the problem and how little was being done about it. And I've been, proud and humbled every day for the last 10 years to have an opportunity to contribute to a mission that I think is so important.
Incredible. Well, I'm glad SEALs are persistent in general. And I'm especially glad that your brother, the SEAL, dragged you along in this important mission.
Yes.
What about you?
Yeah, so we come at this from very different places. I first say I think that SHIELD deserves just enormous credit for, 10 plus years ago, recognizing the need and the opportunity for what we now think of as defense tech at a time when that really did not exist and people thought they were crazy for even trying. Candidly, I don't think we get that same kind of credit. So I grew up flying radio controlled airplanes. I've basically been doing drone stuff my whole life. And that led me to be a grad student at MIT in the late 2000s, early 2010s, when you could basically take radio controlled airplanes and put computers and sensors on them and write software to get them to do smart stuff. So I really became obsessed with trying to build AI systems that could fly better than people could, and wasn't thinking so much about applications at the time. But in 2013, 2014, my lab mate and I started to look out and see there were interesting things starting to happen with small light quadcopters. And we felt like the applications and implications of the technology could be enormous, but needing to have an expert pilot there flying it was just sort of a fundamental restriction. So the big bet that we made when we started Skydio was that AI and autonomy built into a small light quadcopter was going to be very powerful for a wide range of industries. And the government and enterprise applications were always part of the vision. But we explicitly decided to start with a consumer product because we thought that something like light, integrated, easy to use would be a really good platform for this other stuff. And for me personally, when I was in grad school, I was kind of wrestling with, I love this technology. And, I wonder if I want to keep working on it, am I going to have to go work for a defense contractor? And, I deeply believe in the mission of the US military, but the idea of working at a traditional defense contractor was very unappealing to me. And so we started with a consumer product. It's reflective of kind of the trajectory of the space that very quickly, like 2018, 2019 timeframe, and I think to the credit of the U.S. military, they realized that these small, light civilian quadcopters had enormous value on the battlefield, and the technology from consumer to enterprise to military is so tight that in the span of a year, basically, we won our program of record, the Army Short Range Reconnaissance Program, and I think it was officially announced in 2021, but it really started in 2018, 2019. And that was the beginning for us of expanding to serve a much broader set of markets beyond the consumer space.
Adam was also part of my early story. I don't know if you know this, Adam, but I read all of your papers from MIT. When in 2015, we were working on autonomy technologies. I'm like, who knows what they're doing? Oh, Adam. And he has all these great papers.
We've learned a lot since then. But
yeah, it was the foundation.
No, I mean, look, a lot of the ideas that a lot of this ideas that we use at Skydio came from the research community. Some of it research that we had done, some that other folks had done.
Incredible. So one of the things I think has most shocked many and fascinated military strategists is just how drones have reshaped the nature of warfare in the past decade, particularly in the past 3 years.
I think there's just been huge proliferation, right? Far more mass being brought to the battlefield via drones. And it's enabling, much more distributed, decentralized, and lethal force structures, right? Anybody running around in a truck can pop out with a drone that might go 1,000 nautical miles, or a collection of drones that might go 1,000 nautical miles and hit who knows what, far off into the distance. There used to be much more concentration of forces, dependence on large, exquisite assets to deliver capabilities. So it's been just a complete transformation, and the world has seen a lot of that unfold in the conflict in Ukraine. I think one of the major questions is, how can the United States and her allies adopt those lessons? Because the things that we're doing have a lot of merit. It has been a force structure that's dominated the last several decades, but our adversaries have spent a long time thinking about how to counter what we're doing, and I think that it's going to be important for us to think about how we can embrace 100 times more systems, right, to empower our service members to be lethal and effective, to come home safely to their families. And look, I think drones in many ways are the future of war.
Absolutely. And Adam, one of the things particularly shocks those observing the Ukraine conflict in particular is you would see, as Ryan was referring to, say a commercial quadcopter like a Skydio in some instances, they'll go and take out an exquisite system like a tank. 2 or 3 of those packed with sufficient munitions could cripple a large armored vehicle. So how have you seen that sort of shift impact how military looks at dual-use commercial drones?
Yeah, so to be honest, I think that's a question that the U.S. military has not fully digested yet. And one of the realities of drones is that it just creates this massive asymmetry, right? A system that costs a few $1,000s can take out a system that costs a few $1 million. I don't think we fully grappled with that yet, to be honest. I think that we're seeing evidence of this in Ukraine, and the Ukrainians, largely out of necessity and really just incredibly impressive ingenuity, they have a broad array of all different kinds of, ground, whatever you want to call them, like ground robots or drones, air drones, sea drones. They're building that at an incredible rate. They're iterating very quickly, and it's very scrappy. And the U.S. military may not be subject to the same kind of constraints that the Ukrainians are, but I think that we need to understand that the possibility for that asymmetry is real. Like the possibility of building very low-cost systems that are very capable of delivering strikes or capable of maintaining surveillance is very real, and our adversaries are likely to take advantage of it. And so I think that that's a journey that we still need to go on to some extent. There's still quite a bit of inertia and momentum in our military. I mean, I don't know what your experience has been towards like larger, more traditional, exquisite systems. I think that is starting to pivot, but I think that's a real question for us for the future.
There's a phrase used in the military context often. It's quantity has a quality all its own. And there is an incredible disparity between what our chief adversary, the People's Republic of China, can produce in a month for drones, whether it's going to be formal military-style drones or dual-use commercial drones. And that scale I think a lot of people are wondering what that means if in order to deter future conflict or, God forbid, where there would be a conflict in the Taiwan Strait or elsewhere. Adam, would you mind just talking about the sort of differences in scale, just roughly speaking, between the production capabilities of both countries and why that is, particularly on a regulatory basis?
So I mentioned I grew up flying radio-controlled airplanes. So, basically all radio-controlled airplanes were made in China in the 90s and 2000s, and nobody thought nobody was thinking too hard about that. That didn't seem...
Still are, right?
They probably still are, yeah. And, that didn't seem like a national security issue at the time.
Yeah.
But if you think about what a drone is, it's basically like the combination of, radio control airplane type stuff, motors and consumer electronics, a lot of the same stuff that goes into a phone. And, as a country, we basically outsourced manufacturing to China. And I think that was a series of policy decisions, expediency on the part of business. That was a mistake from a military standpoint, because one of the major themes is that the gap between kind of civilian technology and consumer technology and military technology is closing in many of these domains. And so the general manufacturing capacity in China for low cost, capable compute systems, which are really now becoming robotic systems, not just drones, but other kinds of robots, is substantial. And it's not just one single thing, it's a whole ecosystem, and it's not about cost either at this point. It's really about, like technical expertise, built capacity in terms of all the different things that it takes to like mold and machine and build PCBs, the circuit boards, and place components on them. So, I don't think this is something that we can solve overnight. The ultimate thing, and, TBD on if this is attainable. I always say, like, wherever they're building iPhones, they're going to have a really good ecosystem for building drones and other kinds of electronics. And so, the real prize is like, can we bring that level of scaled manufacturing back to the U.S.? I don't know if we can, to be honest, but I think it's worth a shot. And from the outset, as a company, we've been manufacturing our drones in the U.S. And I would say that when we started doing that in 2016, it felt like we were, swimming upstream into like a fast flowing river. I would say that like we're maybe starting to get some like signs of tailwinds, especially with the new administration, which, is cause for optimism. But I think this is one that we can't give up on, because robots are going to become more and more important. Mm-hmm. They're going to be using the same kinds of ingredients from consumer electronics and other kinds of like relatively low cost systems. Cars are going in this direction as well. Cars are starting to look more like laptops and phones in terms of the components that are into them. This is a combination of industry and policy, and all of us working together. And I will say that, like, I think there's cause for optimism over the last couple of years. There's still a lot of work to do, but I don't think it's an insurmountable hill for us.
I've got a, I guess, good news, bad news take. I think the bad news, you sort of led with it. I think that the industrial capacity of China is fearsome. And try as we might, I think that's going to be a very difficult thing to close out in 1 year and even a decade. And, I'm an optimist, and, I'll always like to believe that there's a way. But it is a substantial gap. And I think we're sort of approaching, to use a rocket term, a max Q moment from a national security perspective, where we're undergoing a forced transformation. Huge technology changes are afoot. Things like AI are coming into play. We've got an adversary that's, becoming extremely wealthy, huge industrial capacity, also investing massively in their military capabilities. And so the question then becomes, through this max Q moment over the next decade, given, our production capabilities and the entire capabilities of this nation, what's the right play? And I think that history has shown, World War I, World War II, Vietnam, tremendous amounts of mass were brought to the battlefield. And in some cases, despite tremendous amounts of mass being brought to sections of the battlefield, it just turned into grinded out, war of attrition without a lot of movement on either side. And we start to see some of that in the Russia-Ukraine conflict as well. Tremendous amounts of mass being brought to the battlefield, but front lines that are extremely difficult to move. And I think a reason for that is there's a difference between mass and effect. And, simply, like, the world is big. And targets are relatively small compared to the scale of the world. And it turns out that just throwing a bunch of mass downrange, it can still be pretty hard to hit the things that matter. And where the United States has dominated over the last couple decades is, the software prowess, the AI, the autonomy. And so I think that if we can combine the fantastic work that's going to reindustrialize the United States, to build more mass, to build more capability, we have to do that. But if we can combine it with the software and autonomy capabilities, if we can close like the OODA loop so that we can push software updates at a moment's notice, and make every ounce of charge, every minute of flight time maximally effective, I think that's how we can compete.
There's a second wave that hasn't really broken yet, which is really AI and autonomy. Like the vast majority of what's happening in Ukraine is still basically one-to-one. Like you've got these FPV pilots who are expert operators who are flying the thing, or they're flying drones with very limited kinds of pretty simple mission, like go to these coordinates and deliver a strike. And I think that we are going to see over the next decade another fundamental change, as rather than having these drones animated by an operator on the ground or by like relatively simple algorithms on board, they become animated by really advanced autonomy, and they can communicate with each other. I mean, the implications of that, I think, are probably going to be even more significant than the first step to just having these things be unmanned. And I do think that's an area where as a country, it plays more to our strengths. And, you can't forget about the hardware and the manufacturing capacity. You need to be able to do that stuff, but winning on the AI front, I think is even more important.
So to ensure we dominate, to ensure we win, Vice President Vance just spoke a few moments ago at the American Dynamism Summit, and he said, like, our goal is to essentially remake the economy to fix that mistake that you guys were referencing earlier about we just offshored all of our manufacturing. We can't make things anymore. And there are leading members in Congress committed to that, and also committed to defense procurement reform. So if you had an opportunity to sit down with anyone, the leaders in the executive branch, leaders in the legislative branch, or anyone who'd be listening right now, who's either those leaders or staffers for them, you could give one or two recommendations. Like if you just fix one or two really pivot points, and if those were resolved, we could do so much more, either for drones in particular, manufacturing generally, unleashing AI. What sort of recommendations would you give?
Number one, I would ask that they continue to do what they've been doing, which is reinforce their belief and investments in the incredible people that sign up to serve. The one thing that I think we've got absolutely right is we have brilliant people that are brave. They believe in the values of this country, and they just go and do extraordinary things. And it's been a privilege of mine to be able to meet them. My brother drew me into that universe. And I just think it is such a gift to the nation that we have these people that are willing to do what they do. Now, we strive to contribute to make sure they can be as effective as possible to fight, win, deter, come home safely to their families, and to provide them the best possible tools. And look, what do I know? The administration has hard jobs, so let me put that disclaimer up front. I think the technologies that matter most to the future of war, that matter most to the future of this country and all of her allies around the world, are right there in front of us. And I think the security challenge of our time is whether or not we can mobilize the bureaucracy to go reach out and pick up what's on the table, and everybody already knows is one of the most important capabilities of the future, and that is like taking and making real the large-scale deployment and operationalization of autonomy technologies.
If you look in the kind of space that we play, which are small, light quadcopters that weigh a few pounds that are kind of soldier carried, the Ukrainians today are using these things at the rate of millions per year, literally millions per year. It's the primary method through which they're delivering strikes and surveilling the battlefield. The U.S. military, I think to their credit, has programs generally pointed in this direction, but those programs are operating at the scale of thousands, like single-digit thousands. So we're literally off by like 3 orders of magnitude, I would argue, relative to like what, evidence suggests the modern battlefield demands. And there's similar trends in Israel as well. I mean, Israel has rapidly adopted these class of systems at substantial scale. And this is an area, to the point about reindustrialization, where military purchasing power makes a massive difference. The consumer civilian quadcopter markets are measured in the scale of like single digit billions, which is not out of, that's like comparable, I would argue, to what the military should be spending in the space. They're not spending anywhere close to that today for this class of system. And so I think that's a pretty obvious lever that has a bunch of benefits from a national security perspective. I mean, one, you're equipping people with our soldiers with modern relevant technology, but two, the purchasing power that the military can bring to bear there is significant enough to actually move the needle from an industrial based standpoint for this class of technology that serves other markets. I mean, we all, not just us, but like the companies in our space serve public safety and critical infrastructure inspection, and there's huge technology overlap between the products that you use to do that and the products that folks use on the battlefield.
I think if you just went down all the quantities of everything and just added a zero behind all of them, and then, of course, there's a cost challenge, and, we have to figure out how to do that.
Yeah, I mean, I think there's some things that you can delete, and deleting those things is also painful. It's like
maybe not a zero. Sometimes a zero in front of something.
Yeah. No,
Slide the decimal.
The big zero. Yeah, right.
Well, I think that's the trade-off that needs to be made, right?
Just
like
move decimals around.
Buying legacy exquisite systems that cost hundreds of millions of dollars, some cases billions of dollars. There's a trade-off between like one or two of something, or 10,000 or 100,000 or a million drones. And if you just look into the future, which of those things is going to be more powerful? I think like large quantities of AI-driven drones it's not the only thing that you need, but I think in many situations is the right answer.
Well, let's dive into it a little bit more. So, as you both noted a few moments ago, the U.S. military, starting around the 1980s, 1990s, really went all in on highly expensive, exquisite systems, small numbers. And that worked fine for us. But our now near-peer adversary, China, developed an asymmetric military designed to counter that. So they have a carrier strike missile. So for a cost of, say, 100 million, they take out tens of billions, if not more, on our side, plus the horrible lives we lost. So there's been a move within the DoD to counter the counter, to have a Project Replicator. Let's presume even if we move those decimal points, so all of a sudden the older systems has less procurement, and then the newer systems have more dollars allotted to procure. China, some would argue, still have certain advantages, perhaps because they've had more time working on it, perhaps because they're more subsidized. One of them, people would argue, and I welcome you to say that this is wrong, would be in the area of swarm technology. So you can see the light shows over Shenzhen and other cities for the Chinese New Year, which is extraordinary shows with hundreds of thousands. It broke the Guinness World Record book again this year. Do we have that level of sophistication, and why or why not? And what can we do to make sure that we not only achieve parity if we have not, but achieve superiority in that space?
This is an area that we're quite focused on. And I mean, swarm is sort of one of these terms that can mean a lot of different things, right? And it's really like, what task are you trying to accomplish? So when you see the drone light shows, they're 100% reliant on GPS. So they're using GPS to figure out where they are and to position themselves precisely. And they're 100% reliant on a comms link between all the drones all the time. And both of those technologies are basically like irrelevant on the modern battlefield. It's very easy to jam GPS, and comms is always contested. And so I think that those are representative of their ability to build a bunch of drones and get them into the air, which is certainly part of the equation. But from a core technology standpoint, they're less relevant for the things that I think would be impactful on the battlefield. And we have the great joy of competing against the leading Chinese drone company, DJI, in civilian markets that are unregulated, where customers can buy everything. And our biggest advantage competing against them is AI and autonomy capability. The stuff that we've been able to build into our drones is far more advanced than what DJI has been able to do in terms of being able to sense the environment in real time, respond to it, automate complex tasks and missions. And the advantage that we have, I think, is reflective of our strengths as a country. We were talking about building on academic research. The technology of Skydio is reflective of like a lot of smart investments that the government has made over the years. So I think that like being able to deploy highly autonomous AI-driven drones at scale is still a domain that we can win in. In my view, is still up for grabs, and is something that we're quite focused on as a company.
And Ryan, your company has also invested heavily in autonomy.
Yeah. So our investments on autonomy are kind of going back to one of my earlier statements is sort of predicated on this belief that to make mass effective, it has to be intelligent, right? That's the difference between grinded out, trench situations and being able to assert dominance in a space as if you can, find, fix, and finish targets at scale. So we just think that's fundamentally important. And the first 10 years of our journey was defined by let's strive to make the world's best AI pilot and climb the aviation food chain, which culminated in us doing some work on F-16s that has circulated the internet. When we thought about the next 10 years, the question was is the future really about Shield AI building the world's best AI pilot, or is it about making a contribution to the industrial base so that everybody that's building these systems across America, building sort of incredibly sophisticated machines, striving to do it at larger scale, can now, deploy the best possible AI pilot for their vehicles for the customer's missions. And we think our best and highest contribution is to enable the industrial base to fast forward the large scale deployment of the world's best AI pilots.
So in Ukraine, you see, drones come up, drones come down. Oftentimes they're DJI drones in a matter of minutes or seconds, many times failing in the mission. How have you thought through how your drones can operate in a battlefield where there is a high degree of electronic warfare? So you do not have access to GPS. You don't have access to reliable signals to the controller and operators.
When we started the company, we made a huge bet on computer vision as the right technology for AI and autonomy. And this was back in 2014 when it was much less clear than it is today. So just sort of natively, our drones have a bunch of cameras. They look out and see the world. They use that to figure out where they are and how they're moving and what's interesting and important around them. So, we come from a place of not being reliant on GPS, having more of an ability to do onboard things. Having said that, candidly, our first round of drones in Ukraine basically failed. And we had built the system largely informed by the U.S. Army's requirements for what they thought was important for a quadcopter in this space. And electronic warfare was just nowhere on that list. And so from a radio standpoint and from a navigation standpoint, our first generation system was just not set up for success. And it was a painful process for us. So I've been to Ukraine twice myself. We had a bunch of folks on our team spend a bunch of time there, and we learned a bunch of hard lessons about what it takes to really operate in this environment. And that really started to drive our development. And more so, honestly, than the requirements coming from the U.S. military. We made an explicit decision as a company that we think this is the real world situation that matters, both from an immediate impact standpoint, but also whether or not they realize it, this is what everybody else is going to need as well. And so there was a process for us that really took a couple of years of adapting the sort of native vision AI primitives to work in this environment, which we've now gotten to with pretty phenomenal results, where the drone is incredibly resilient and capable in both from both a comm standpoint and from a GPS denied navigation standpoint in extremely harsh environments. But it's a real technology hurdle to get across. And we're now seeing this, the bet that we made is in many ways paying off. We're seeing this with other militaries around the world. They're starting to come around that this is the kind of thing that matters. And our systems are performing. Now electronic warfare testing is becoming part of the evaluation protocol for a lot of purchases.
I think Adam hit the nail on the head. The effectiveness of your systems in an EW environment is the difference between whether they're relevant or not. And a lot of people will say that our next generation product is going to work in an EW environment, but I think that's hard to say unless you're actually doing it. I mean, that's a pretty tall claim. Another element of effectiveness in these complex battlefields, I think it's just the adaptability of your capabilities of your software. So, anecdote from Ukraine, to solve for this environment, which is constantly changing, we were going to go out. We have a product called the VBAT. It's a plane. It's 12 feet tall, 12-foot wingspan. I can fly for about 12 hours. We got sort of the brief from the Ukrainians and the situation that we expected. Here's the situation. You guys are going to take off. You're going to go this way, maybe 70, 80, 90 nautical miles. you'll have GPS on the ground. As soon as you get to 200 feet, the jammer is going to hit you, and you have to have no GPS from that point forward. So engineering team's like, great, got it, good. We'll get the fix on the ground. We'll take off. We'll go take care of business. It's gonna be sick. We go out there, and at like 3 feet, the airplane loses GPS, and so the Ukrainians are constantly jamming too. So Russians, Ukrainians, because if the Ukrainians stop jamming, they find themselves at risk. Even if you're launching on the friendly side, there's intense jamming at 3 feet off the ground. Turns out. So the airplane takes off and it just starts flying the other direction. I don't know if you've seen the movie Interstellar, where he's going through the cornfield. The dude has a laptop and he brings down the drone. Our team and the Ukrainians just took off in a truck and chased it for about 2 hours and found it orbiting over a cornfield about I think like 80 kilometers away. And in the span of 24 hours, the engineering team re-architected the stack to not use GPS at any point in the mission. We validated it at our Texas facilities, and then we pushed it forward. And 24 hours later, the team took off and then conducted a demonstration that was written about in the Wall Street Journal, where the outcome of it was ultimately a Russian SA-11 getting found, getting fixed, and finished by a HIMARS. I tell that anecdote because it will be the pace of deployment that is the make or break for militaries around the world. If we want to make a software change in some of our programs, it can take up to a year, right? It is considered a big deal to change the software. When we took that aircraft forward to Ukraine, we wrote new software in 24 hours. We pushed it, and then we needed 24 hours to properly plan the operation. And unless we find a way for industry and government to work together to deploy software capabilities at that pace, we will find ourselves in a very tough situation.
In a world where you're using autonomous systems, everything is basically software defined, right? The entire behavior capability of the system is software defined. Electronic warfare is also software defined. Like the behavior of the jammers and everything is coming largely through software. And so in many ways, I think a modern conflict, and you see this in Ukraine, becomes basically like a software writing fight. And the speed at which you can write it and deploy it really matters. And I just I have no choice but to be hopeful and optimistic here, because we've had the same experience where sometimes it's taken us 2 years to push new software into deployed systems. I would like to think that if we were actually in a conflict, that would just evaporate and we could do it in a day. Maybe that's overly optimistic and hopeful, but I think that's one where the status quo is unacceptable.
Again, two exceptional stories. So we're discussing autonomy, and one of the concerns either of you may hear from time to time is that, well, if you have autonomous drones, that means humans are not in the loop, and that means we're ceding our authority to essentially software. Is that an accurate assessment? What does autonomy mean in terms of humans actually having control over what the end state of what the drones are doing? And how do we best configure the military and also civil society to a future where autonomous drones are not only available, but cheap, widely adopted?
The first thing to say, and this is really, I think, the important backdrop for all of this, is that this is terrible stuff, right? I mean, we're talking about weapon systems that kill people and create immense suffering, and that is the reality of war. The real goal for everything is to act as a deterrent and to make conflict less likely, and to make it such that if conflict does happen, you can be maximally targeted and precise, and minimize human suffering. I think that's just sort of like an important backdrop for all of this when we're thinking about what we do and the kinds of systems that we're building. Now, I think there's a bunch of legitimate concerns about, what does it mean to have these AI-driven robots, and how automated are they going to be, and how much authority are we going to delegate to them? I think the thing that we have to also keep in mind is, unfortunately, the game theory here is just as simple and obvious as it can be, right? Like, nobody thinks nuclear weapons are good for humanity on an individual level. Deploying a nuclear weapon is like a miserable, terrible, terrible thing. But the only world worse than one where like you and your adversary have nuclear weapons is one where only your adversary does, right? So I think one of our strengths as a company, or as a country, is our values and the way that we we try to conduct conflict with a high ethical standard. And I think that it's important to maintain that. One of the things that I've been impressed by is really the level of sophistication within the military on these issues. I mean, there's people whose job it is to think deeply about the implications of different kinds of weapon systems and how authority is delegated. There's very robust controls in place for how the military thinks about these systems. Those things are evolving as the technology evolves. But, this is something I've thought quite a bit personally about. The more that I've thought about it, the more time I've spent with the military, the U.S. military in particular, the more comfortable I've gotten that, like, this is a robust organization that cares about doing the right thing, is thinking deeply about the implications of technology. And, my general view, which I think is shared by military policy and doctrine, the U.S. military policy and doctrine, is that, like, ultimately human judgment is really important, right? A human exercising judgment in how force should be used is super important. But the other thing that people have to understand is that the status quo is not great. I mean, like, oftentimes, your choice if you want to take out a target is dropping a 500 or 2,000 pound bomb, which is going to cause widespread destruction and a lot of collateral damage. And so an AI system that might be using autonomy to, like, a pretty intense degree to figure out, like, where something is and what to do about it is probably better than dropping a 2,000 pound bomb and blowing up a whole city block. And so I think you've always got to be thinking about, like, what's the status quo, and can we use AI and autonomy to better, more precisely accomplish the thing that we care about while inducing as little human suffering as possible.
Maybe the good and true news right now is that I think human machine teams are far more effective than, like, machine only teams right now. And, for the next, several years, I think that that'll continue to be true. And maybe it's true for longer than that. And the frameworks that we have in place, people are in the loop on the decisions, make a tremendous amount of sense. I think Adam brings out, an excellent point. The game theory is one that, right, if somebody finds that a machine-only team is the most effective team in certain missions and circumstances, the question is, like, why and when would that be used, and what do you do about it, and how do you make sure that you're ready for it? And so I don't think you can live in a world where you have blinders. So if you just, I was speaking to a senior military leader that had a nice framing, which is his expectation is the more defensive you end up being, the more likely you are to turn things over to machine control to get the very fast reactions and the dominance that you need to come out of that situation. And so, like, a great kind of very practical example of that today is the phalanx gun system that protects ships, right? If you come into that thing's weapon engagement zone and it's turned on, it will kill it, right? And so you can think about that, at a larger scale. If a force is pressing on another force, they find themselves in a defensive situation, and they flip the switch and they go full auto. What does that mean, right? And how does that get put back in the box? And tactically, what does that mean for your forces? Were they trained to face something that had that level of capability and that level of discretion, that level of speed? And then how does it play forward from there? And so I think that there are a lot of hard questions. I think that, like, the convenient answer, the easy answer is that humans are always going to be on the loop. It's going to be fine. Don't worry about it. But I think that, the world is a little bit more complicated than that. I don't have answers for it other than strong conviction, like, that America needs to lead. So sort of no matter what you believe about any of this, whether you have conviction on one side or the other, or you're just uncertain what the future is going to be. And I think there's a lot of uncertainty about how the future will play out. American leadership is the answer.
At the conceptual level, a lot of these things are less new than they seem. So, like, dropping a bomb in World War II, like, once that thing leaves the bomber, it's autonomous. Now it's pretty dumb autonomy, but there's no, human judgment is over, right? Like, that thing is falling and it's guided by gravity and wind and physics and other things. And at some point in that trajectory, if it starts heading towards the wrong place, or you realize that it was the wrong target, there's nothing you can do about it. We are used to relinquishing control over the end outcome. And usually that results in, like, much less precision and much less ability to actually accomplish the thing that you care about. And AI fundamentally changes that equation. But I don't think that the concept of, like, a human relinquishing control over the ultimate thing that happens is actually new.
Both of you question the premise that this is a new thing that's never happened before. It is not the case. And second, both of you zoomed out and said, listen, we are not at the end of history. Fukuyama was wrong. There are rival systems of government, totalitarian states and free states, and we have to make sure, whether your concerns may be, in a conscientious, thorough, and democratic manner, we ensure that we are the ones who have dominated this technology to ensure deterrence. Now, let's imagine two different futures 10 years from now. One, where totalitarian states, China, Russia, et cetera, has dominance over this technology. They not only in terms of procurement, in terms of production, but also in terms of technology. And another where we maintained and then advanced our technological advancement and lead over them, and also achieved manufacturing, at least parity, if not superiority. What do those two futures look like?
It's hard to predict exactly, but I think AI is the most important technology really in the history of humanity. And a world where our adversaries have it and we don't is not a good one. I mean, a world where like the Soviet Union had nuclear weapons and we didn't. A world where Nazi Germany had nuclear weapons and we didn't. I mean, these are not pleasant things to think about. And so, in my standpoint, I think we should just view that as an unacceptable outcome, like one that we cannot allow. And some of this plays out like beyond the military domain, but I think there is, in AI, and I think this is changing rapidly for the better with the new administration. There was a lot of talk of like safety and regulation, and we can't do this, and we can't have this many parameters, and if you use more than this much compute, it's like it's not allowed. Like if you're sitting in Beijing or Moscow, I mean that's just got to be music to your ears, right? Of like, please, yes, like slow down, be like, right. Like, and so I think that it's not to say that we shouldn't be thoughtful, but like we've got to be real about the game theory dynamics here, and the implications for this technology.
So to close out, there are, I'm sure, a number of founders watching online, and I'm sure many of them would be interested in getting into public safety, defense tech, want to make a difference. They see the mission, they see the need. Perhaps they're scared, they're afraid of failure. They don't know how to start. If you were to give just one piece of advice to these founders or would-be founders, what would it be?
Number one, the mission is worth it. I don't think that there is a thing in the world that you can care about that doesn't build from a foundation of security and stability. And I wake up every day just incredibly excited and honored to have the opportunity to contribute to something that I think is so important.
The other thing I would say is this stuff is just extremely challenging. And I think that, especially if you're building hardware and you're serving these critical industries where like the stakes are really high, you should just expect it to be really hard. And it's hard in different ways at different points in time. But at some level, I think to be successful at it over the long term, you've got to kind of love that. And I think probably both of us, different things in our backgrounds, we do. I mean, I love the challenge of trying to solve these difficult problems. And I think, our company, probably both our companies tend to attract people who want to be really pushed and challenged and work on hard problems and struggle with things over days, months, years. And that is definitely part of the journey here. If you want to get to something that is going to have real impact, is you got to embrace the struggle.
100%.
Wise words.